Okay, let's look at 22C. 22C is tree diagrams, and the idea is the probability of successive events. Where's my marker? Here it is. No, there. So we're going to look at the aim is tree diagrams. And the idea of successive events. Now, in the last lesson, we talked about the probability of like two or three things happening for like one event. Like I pick a kid in the class, and what is the probability that they take Spanish and biology? Or I pick a toy out of the basket, and what's the probability that it's red and small? So in this case, though, we're looking at the probability that two or more events are going to follow each other. So here's our example. You go to school. Okay, and you can either walk or ride your bike, and you can I'm in Bangladesh now. If you watch this video in the future, you can get to school by taking Park Road, or you can get to school by taking UN Road. Okay, and the probability that you ride your bike is 15%, and the probability that you walk is 85%. The probability that you take Park Road is 35%, and the probability that you take UN Road is equal to 65%. The question is, what are all the outcomes? What are all the outcomes? Well, there's four possible outcomes. The four possible outcomes is you walk and take Park Road, you walk and take UN Road, you ride your bike and take Park Road, or you ride your bike along UN Road. The question is, how do we represent this? So the first thing we want to do is a tree diagram. So we'll start with a tree has branches. Start with the root and goes off. So the first set of branches start from this point and they go out. Now at the end of the branches, we're going to write the event. So what did I hear? First, the first thing is, this is the first event. The first thing is my first decision. I either ride my bike or I walk. So at the end of the branch, you write the actual event. On the branch, you write the probability. So the probability that I ride my bike, what did we say, is 15%, and the probability I walk is 85%. Now, this is the first event. Okay. The next thing we want to deal with the second event. So I've decided on riding my bike or walk, and I have a new decision to make. That's I either take Park Road or UN Road. So I make two new branches. Same idea. Either, what did I do on my notes? I Park Road or UN Road. Park Road, UN Road. Okay. So, and once again, we write the probabilities over here. So the probability of Park is 35. You can write it down here. And the probability that I take UN Road is 65%. Okay. Now, the question is, what is the probability of successive outcomes? So in this first part, we're going to be able to say the probability of A and then B, or A and B. We're going to have to change this a little bit. But the probability of A and then B is the probability of A times the probability of B. Right? So let's see. So we have here the probability of bike and Park Road is equal to 0.15 times 0.3, or 15% times 35%, which is 0.0525, 5.25%. What's the next outcome? That's the probability that I rode my bike and I took UN Road. Well, that's 15% times 65%, which is 0.0975. Let's see. Let me use a different color. I'll use blue here. What's the next thing that can happen? The probability that I walked and I took Park Road is equal to 85% times 35%, and that's equal to, let's see, 29.75%. And the last possible outcome is the probability that I walked and I took UN road. And that's 15% times 65%, and that is 0.5525. So a couple of interesting things about this tree diagram. It turns out that 0.5 plus 0.5%, 5.25% plus 9.7.5 equals, if you add these together, you get 15%. And if 29.75% plus 55.25, that equals 0.85%. It's not a coincidence. And even cooler, 15 plus 80, that gives you your 1, which means the sum of all the probabilities equals 1. So it's coming back to that first state of probability that the sum of all the outcomes is equal to 1. It's kind of cool. Let's move on. But the next thing I want to talk about is something called conditional probability. So let me erase this. And we're going to change this for IB, conditional probability. Okay, the next thing we want to talk about is something called conditional probability. Probability. And so the idea is this word you're going to see is given. Okay? And so the notation is you're going to see P, A / B. And this is read as the probability of A given that B has occurred. Now I know the orders of the letters. They have to put A and B. The idea is whatever is here, let's change it. Let's use I don't know, Q and K. This means that K occurred first, and then Q happened. Let's pick another. I don't know. How about D and Z? Well, let's change it. Here's W and D. This means D occurred first, and then W. So, but what's the point? Well, the idea is sometimes I will choose a second event given so for example, maybe in the first example, I'll go on Park Road. There's a 10% chance I'll take Park Road if it rained, something like that. So some events affected a future event. So here's an example. Let's see. This is from the book. If I study, there is an 80% chance I will pass. Okay, the test. Is everything in there? Nice. Next thing, but if I don't study, there's a 30% chance of passing. But if I don't study, there is a 30% chance I will pass. So the question they want to know is, I study 75% of the time. I study 75% of the time. So now we can answer a couple of questions. The question is, what do they want to know? What does the book say? So the question is, what percentage of the test do I pass? What percentage of the test do I pass? Okay, well, let's get the notation. If I study, there's an 80% chance I will pass the test. But if I don't study, there's an 30% chance I will pass. I study 3/4% of the time. Okay, let's get some notation down. So let's call it S is study, P is pass. So the probability that I study is 3/4. So what's the probability I don't study? Well, that's 1/4. Okay, let's continue with this. What else do we know? If I study, then I pass the test, which means the probability that I pass, given that I study, is what? This is 80%. And the probability that I pass, given that I didn't study, is equal to 30%. So let's get a tree diagram down and see how much we can fill in. Because we always want to do a visualization. Data science is a big thing. So let's get a tree diagram. I'm going to erase this up here. Oh, sorry. Let's get a tree diagram. So let's start off. Study, not study. Study, not study. So we have 3/4 and 1/4. What's going on with these branches out here? Well, this branch here is study. This is pass, given that I studied. Over here, this is not pass, given that I studied. The third branch is pass, but given that I didn't study. And this is pass, not pass, given that I didn't study. Now, this is different because your passing depends on a previous event. It didn't matter. In my last problem, it didn't matter, if I took, a bike or I walked. There's still the same probability. But in this case, the second event is affected or depends on the first event. So let's get the probabilities up here. Let's see what we can do about this. Well, let's see. If I study, there's an 80% I will pass. So this is 0.8. I don't know what that is, and it's not 20%. That's not what we know. That's not how it works. Let's see what's going to fill at anything here. Let's see. And then we know that if I don't study, then there's a 30% chance of passing, so that's 0.3. Now, the question is, can we fill in the other branches? We could, but we don't have to. Let's think about this. What are they asking for? They want to know the probability that we pass. What is the probability of passing? Well, it's all about the branches. And the question is, what are the branches of passing? And you go, oh, well, it's the first branch. It's the first branch and the third branch. So if you think about it, the probability that I pass could happen two ways. It's either the probability that I studied and then I passed the test, or I didn't study and I passed the test. Once again, the probability of the first branch is the first branch times the second branch. And the probability of the third branch is of 1/4 times 0.30. Let's put those numbers in. So we have 3/4 times 80% plus 1/4 times 30%. Did I write the answer out? And 3 divided by 4 times 0.8 plus 0.25 times 0.30, enter 0.675. So there's a 67.5 chance you're going to pass. Let's go on. So please remember, nice. Please remember what depends on what. So this, once again, passing a test depends on the amount you study. Let's go on. Let's do some problems from the book. because I think the best way is to do some problems. So remember, so in the book, here's the confusing part. In the book, they don't write it like that. They write it like this. So I mean, I read this, I'm like, oh, I think A came first and B came second. No, in this example, let me go back to the video so I can see myself. In this example, I want you to look at the conditional statement. I want you to look at the given statement. This is what I want you to focus on. You look at that and you say, oh, B happened first. So whenever you see these problems, when they start these probability problems, they start given this, given that, you go, what happened first? Once again, A occurred and B occurred. We're just not really sure which came first, which influenced the other. But the second you see this statement, you're like, oh, B happened first and then A happened, given that B was affected. So that's what I want you to pay attention. So let's look at the first problem. So problem 1. They say that the probability of A is equal to 0.4, and the probability of B given A is equal to 0.3. They say find the probability of A and B. That's no big deal, right? You say, okay, you look at this and you say, what information? They say, oh, you know what? We see here, oh, B given out, oh, so we know that A happened first, and maybe I might want to do a tree diagram. Maybe the first thing was A, right? And then I see here, oh, B followed A. And so this branch is equal to 0.12. So that's the probability A and B. Let's look at, so this is 1A1. Let's look at 1A2. 1A2, they say that it's the same problem. They say that the probability of X is equal to 3/5, and the probability of Y given X is equal to 0. So what is the probability of X and Y? Whoops, I'm sorry about that. Y and X. Okay, so what's going on here? So once again, you're not really sure what came first because I can switch these around. But I want to see the conditional state. You know what? X was first. X is first. So I know first it's X, and then X given Y. So what's going on here? Well, the probability of X is 3/4. But the probability of Y happened. Sorry. The probability of Y given X. Well, what happened? What was the probability that Y was going to happen given X happened? 0. It's just avoided. Like, I don't know. You can think of some events. You know, what's the chance I go outside given there's a torrential hurricane? Well, it's 0. So here, the answer is 3.5, 3/5 times 0, which is 0. It happens. 0 is just a number. It's an outcome. Let's look at the next problem. There's a mistake in a 1B1. 1B1. And so they say the probability of A is 0.3. They say the probability of B is 0.2, and the probability of B choose A is equal to 0.8. And once again, they want to know, they say in the book, they want to know the probability of A and B. For reasons I'll get to in a later unit, I know that's a mistake. There's no way the probability of B can be less than like part of itself. Because we saw up here, the probability of passing is, oh, no, you know what? I'm not right. But I think maybe they wanted to do the union or something like that. That might be it. Oh, I see. Okay. So, well, we're just interested, if they want the probability A and B, we say, oh, you know what? A happened first. So I make my tree. I'm like, okay, fine, the first thing is A, and then the next thing is B, given A happens. Well, the probability A is 0.3, the probability of B given A is 0.8, and so the answer is simply 0.24. Maybe the book wants something else, but that's the answer I saw on the back of the book. Let's do another one. 1C1. Let's erase this. Let's go on. Let's go on. 1C1. We're told that the probability of A is 3/5. The probability of B is 1/5. The probability of A given B is 1/4. And they want to know what the probability of the union of A or B happening. Now, this is the theoretical part. This always shows on the part 2. So let's see. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the intersection. So what's going on? Well, so we have the probability of A and we have the probability of B. What's the probability of A given B? Well, that's fine. We know that B happened first. So we know that there's a B, and then an A choose A given B. We know the probability of B is 1/5. We know the probability of A given B is 1/4. So we have here the union is equal to 3/5 plus 1/5 minus 1/20, which is equal to, 4/5. Which is equal to, let's see. Oh, this is 2/5. Sorry about that. 2/5 plus 1/5 minus 1/20. Let's see. So we have 3/5, which I'm going to write as 12/20 minus 1/20 equals 11/20. This is your part 1 questions. This is where, this is very theoretical. This is important for your early probability. When you take an intro to prop stats, this is the stuff that shows up a lot. Let's try another one. Number 2. Number 2 has to do with the marbles. There are 6 boys and 8 girls in a class. And the question is, what is the probability that you choose 2 boys? The probability of a boy and then a boy. So this falls under the header of with or without replacement. And so the idea is, do the probabilities change? Does the probability now get affected by what happened in the past? So let's see what's going on here. What's the first thing? Well, I have 6 boys and 8 girls, which means there's 14 kids in the class. Let me lower my screen. So the question is, what does my tree diagram look like? So you say, okay, fine. The first branch is either pick a boy or a girl, assuming we still have only 2 genders. So we have a boy and a girl. The probability of a boy is 6/14, and the girls is 8/14. What does the next set of branches look like? So once again, I either pick a boy or a girl, and I have a boy or a girl. Well, this branch is not 6/14. This branch is now, there's only 5 boys left, and there's only 13 kids left. For the first girl, I only picked boys, so I still have my 8 girls left, but there's only out of 13. It's interesting, the probability increases for these. What's going on here? Well, I picked a girl, which means for both cases, I only have 13 kids left over. But I never picked a boy, so this is 6 out of 13. And in this case, it's 7 out of 13. So I can do all the probabilities, but I'm interested in boy and boy. So look at the boy and boy branch. Once again, it's all about the branches. So you're like, okay, it's this first branch up here. It's the probability of a boy times the probability of boy, which is interesting given that you picked a boy. because the last boy, because once again, I didn't put the boy back in the, like, imagine a bag of marbles and I didn't replace it. Same thing here. Once that kid is picked, he doesn't get to get picked again. Anyway, we have 6 over 14 times 5 over 13, which is equal to, what I have, let's say I can't, let's see, this is 3 over 7. So we have a 15 over 91. 15 over 91, whatever that is as a decimal. Let's try another problem. In the next case, you can try this on your own. In the next case, we have a bag of marbles. So question number 3, you have a bag of marbles. How many marbles are there? Well, it looks like there's 4 red. It looks like there's 2 green. And it looks like there's 3 blue. And the question is, what is the probability? The question is, what is the probability that you pick? That you pick a green and a red in any order? So the probability of green and red in any order. And the idea is, there's all these branches. You need to pick the 2 branches. So the first branch has green and then red, but then there's another branch that has red first and then green. And you add these probabilities together. First of all, you make the 2 branches. You'll also notice in the question, it's without replacements. Without replacements. So once I take that, so how many marbles are there? Let's see, there's 9 marbles. So the first probability would be 2 over 9. But then, so this would be 2 over 9 times, but then it's going to be 4 over 8. What's going on over here? Well, the first red is 4 over 9 times 2 over 8, which ends up being 16 over 72. What is that? 8 over 36, 4 over 16, 2 over 9. So there's a 22% chance that you're gonna pick a green and a red in any order. Is there another problem I want to do? Yes, one last problem. One last problem I want to do, and then we're done with it. You can work on this. Let's see. So the last one's kind of interesting because this is where they get tricky. This is like your 6-7 problem, and this comes back to something they don't teach it anymore. It's really old school, but I think it's kind of cool and really important. So they say, the question is, the probability that X is 1/3. The probability of Y, given that X occurred, is 2/9. And given the probability of Y that X did not occur is 1/3, right? They want to know, this is kind of cool, they want to know the probability that Y happened, and they want to know the probability that the union of not X or not Y. Well, once the second you see, all these conditional probabilities, make a tree. Make a tree. So you're like, fine. It's clear that X or not X occurred first. So I know there's X and we know there's X and not X. That's fine. And we know the probability X is 1/3. Therefore, the probability of not X is 2/3. Fine. We also we know that Y and not Y happened after X. Fine. So this is X. This is Y given X, and this is not Y given X. Also, we have not Y. This is X given not X. Y given not X, and this is not Y given not X. These are the 4 outcomes. X, Y, X, not Y. Not X, Y, not X, not Y. Fine. Do we have the probabilities for some of these? Yeah. We're told that Y given X is 2/9. And we're told that Y given not X is 1/3. Now, the first part is easy because the probability of Y is all the y branches. Where are the y branches? You say, okay, they're right here, Mr. Adler. This is the first. So the probability that y, it's either this or it's branch 3, conveniently giving you all the information you need. Once again, we're going to come back to this. The idea that y happened is that y happened times the probability of y. The probability of y is equal to either the first case that x happened first and then y happened, given that x happens, or x didn't happen, but y still happened. Well, we have all this. Once again, this is the first branch, and this is the second branch. Y can happen in 2 cases. Either, let's see, once again, let me go over that. There's 2 possibilities of y happening. Either x happened before it or x didn't happen before it. That's fine. So the probability of x is 1/3. The probability of y, given that x happened, is 2/9. Plus, either x didn't happen, and x didn't happen, and then y still happened, given y x didn't happen. So this is now, so we have 2/27 plus 2/9. Let's multiply this by 3/3 to get 6/27, and we have 8/27. Is that right? Nice. Oh, that's not what they asked. Sorry about that. That's not what they asked. They asked for, I apologize, they asked for not y. Well, that's easy, right? If the probability of y is 8/27, what's the probability of not y? 19/27. Nice. But we have that last part to deal with. Now that's weird. We don't. I've never seen that before. But we could do the long way. Or we could do a little trick. I'm going to show, since you're not taking the exam this year, but in the future you might. I'm going to show you a little trick. Ready? You recall, I'm going to erase this. If you recall on the day that we did Venn diagrams, this looks familiar. This kind of looks familiar. So let's see if we can recall that. So we have x and we have y. Okay. And so let's make x red and let's make y blue. Okay. So not x. Where's not x? Well, this is not x. This region is not x. Okay. Well, where's not y? So you go, okay, Mr. Adler, this region is not y. Well, it's just so interesting. You go, oh, wait a minute, Mr. Adler. You just shaded, it says it's the union. You shaded everything. But what didn't I shade? Well, I didn't shade the intersection. And so we recall, this is De Morgan's law. This is actually equal to the probability of not the intersection. Well, we know that's equal to 1 minus the intersection, and we're basically done. Well, we know it's the probability of x times the probability of x, y, given x. So we have 1 minus 1/3 times 2/9, 1 minus 2/27. Final answer, 25/27. And that's the answer. So this is your abstract thinking. This is your part 1 questions. Good luck with the rest of the questions.